Hi, I am Sergio Mora. I am 10 years old, and I will explain synthesis modules. Okay, so here we have our synthesizer. We can clearly identify the parts and the modules of the synthesizer. Here in the lower part, we have our oscillator. We have 3 oscillators. I will be working just with the first one. In the middle part, we have our LFO and our filter, and in the right corner, we have our amplitude envelope. Okay, so the oscillator is the first part, the first step to create a sound. The oscillator often has a waveform. So here we have that there is an extensive list of waveforms. So let's try just some. For example, we have here our sawtooth. We have some clear changes in the timbre. Let's prove just a sine. Okay, so here's the oscillator. After this, we pass to the filter. Let's remember that the oscillator helps us to create the first step of the sound, and it has commonly a lot of highs. So next we pass to the filter. The filter allows us to manipulate the highs from the oscillator, and we can manipulate here in the filter a low pass filter, a high pass filter, and a band pass. Here we can change the cutoff and resonance. Without the cutoff and resonance, it seems more like this. I'm working with a sine wave. The cutoff, as we increase it, it allows us to have more harmonics. Let's hear it better with another. We can hear the harmonics of the main note. Here we don't. And resonance allows us to have the harmonics of a high pitch. We can hear. After our filter, it passes to the amplitude envelope. Attack, remember, is the time it takes from 0 to the highest point. Then decay is from the highest point to the sustained level, and the sustained level is the level where the note sustains itself when it is held on, and the release time is the time it takes from the sustained level to 0 again. So let's modify this and see how it works. I will increase the attack. It takes a little more to reach to the highest point. And let's hear it again. So as we can hear, the attack was high, so it takes a little to reach to the highest point. Later we hear that the sound begins to decay, and it reaches to a point where it was sustaining until I left the note go. So the release was very low, so when I stop playing the note, it stops the sound immediately. And then we have the LFO. The LFO functions more like well, it's a low frequency oscillator, so it functions with frequencies that are behind the human range of hearing. It functions commonly from 0 Hz to 20 Hz, and this can change cyclically many things. We can increase the frequency to make it a little bit more evident. Let's hear it like this. And that vibrato at the ends is what is being modified by the LFO.